We shall discuss compiler design now. The main aim of compiler is to convert a high level language into a low level language. Then the question is, if you have to convert the high level language into low level language, why don't we write a program in a low level language? The reason is we are not comfortable writing programs in zeros and ones, the binary language. We are comfortable writing it in English language or some language similar to English, and then compiler is a software which is going to convert that high level language to low level language. Along with the compiler, we have many other software modules which will help us here. So if you look at this diagram, I'll tell you what are all the phases available. See, first the high level language will be given to preprocessor. Then the preprocessor is going to convert that high level language into pure high level language. For example, what is a high level language and pure high level language is, if you write a C program, the starting lines are going to contain hash include, isn't it? Or it is going to contain hash define, right? So if a program contains such lines, then it is called high level language, and preprocessor is going to remove these lines. Removing hash include by including the file, that is also called as file inclusion. File inclusion means whatever file you want to include, the preprocessor is going to substitute that entire file in your source program. Okay, and the second one is hash define. For example, sometimes you might have to define a constant and you don't want to write its name. Let me tell you an example. In some programs we might need the value interest provided by the bank, and the interest is variable, right? It is a constant, but then it is a variable. Therefore, if anywhere the interest has to be changed, you cannot go to the program and then mechanically manually change all the places where the interest is. Instead of doing that, you can just change in the define line, hash define something. Okay, so if you have hash define and hash includes, you can have hash define some constant. If you change the value of hash define constant, it is automatically going to be reflected. So it is called macro expansion. Sometimes we are going to write macros also. Macros are nothing but small functions for which we don't want to really call a function. Function calling is a overhead, macro calling is simple. That is why we go for macro expansion. So preprocessor is generally going to do these things, file inclusion and macro expansion. Now after the preprocessor phase, we are going to enter the compiler phase. And the input to compiler is pure high level language, which means the program will not contain any hash lines, any hash tags. And these hash tags are also called as preprocessor directives. They direct the preprocessor about what to do. Okay, so the next phase is compiler. Compiler will take the pure high level language and it will convert into assembly language. For every platform, by platform I mean the hardware that you are using, for example Intel or AMD or Motorola, this is the hardware you are using. On top of it, the operating system, for example Linux, Windows, 64-bit, 32-bit. So depending on your hardware and the operating system, which is also called as platform, we are going to have some assemblers. A assembler for one platform will not work for other platform. For example, you can think of assembler as a manual which is using which you can only operate one instrument, you cannot operate other instrument. Therefore, the main purpose of compiler is to generate assembly level language, and assembly level language will be not entirely in zeros and ones and not entirely high level language. So it is somewhat intermediate. Previously, long back, people used to write programs in assembly language too, and later they came to high level language. Okay, before compiler they always used to have assembler. And once the assembler take this assembly language, it is going to convert the assembly language into machine code. So machine code is it is zeros and ones. But then there are two types of machine codes. One is relocatable machine code and other is absolute machine code. Relocatable machine code means you can load that machine code at any point in the computer and you can run. In the sense, compiler assumes that it doesn't assume anything. Compiler doesn't assume that you are going to run a program only from particular memory. If you have the memory RAM, in that RAM, compiler assumes that you can either start from this point or this point or this point. Therefore, all the addresses within the program will be in such a way that they will cooperate for the program movement. While running the program, you can move it. Okay, and loader and linker will take the machine code which is relocatable and then convert it into absolute code. Okay, so let's see what, if you talk about any compiler like GCC or turbo C compiler, all these phases are included. Okay, so but then actually compiler means only the part which converts pure high level language to assembly language. But if you look at GCC, you need not do pre-processing separately, assembly separately, loading linking separately. Everything will be kept in a one tool. Now in this course compiler design, we are not interested in looking at all the tools together. We are only going to look at what a compiler is going to do. So let's see what are all the phases available in compiler. So first one is lexical analysis phase. Lexical analysis phase will take the program and read it and then convert the program into tokens. That is also called as stream of tokens. And next, this stream of tokens will be given to syntax analyzer. Syntax analyzer is also called as parser sometimes. And syntax analyzer is going to take the tokens and convert it into a parse tree. And now parse tree will be given to semantic analysis. And now semantic analyzer is going to again verify whether the parse tree is meaningful or not. That is called parse tree, which is semantically verified. And now this parse tree will be given to intermediate code generator. Intermediate code generator is going to generate 3 address code. There are various 3 address codes we have, and here there are various intermediate codes we have, and 3 address code is very popular. And now the output of this intermediate code generator will be given to code optimizer. The main purpose of code optimizer is to reduce the size of the program or is to reduce the number of lines. And then it will be given to target code generator. And target code generator is finally going to generate the assembly code. And during all of the phases or the entire software modules are going to take support from something called as symbol table manager. So we shall see all of them in detail by taking an example. You will understand more when I take an example. And moreover, all of them are going to talk with a module called error handler. Okay. So we shall take an example and see what do I mean by stream of tokens and what do I mean by parse tree, what do I mean by semantic verification, 3 address code, optimization, target code generator. I'll take a single example and I'll explain you all the phases in that example. Okay, fine, got it. Yeah, let's see an example about how all the phases are working. The example is x equal to a plus b into c. Let us say that is the source program we have given. Just for the assumption, the source program is just one line, x equal to a plus b into c. Nothing but you have to multiply b and c and then add a and then store the result in x. First, this one will be given to lexical analyzer. Once the lexical analyzer receives the input is converted into a stream of tokens. That is the main purpose of lexical analyzer, right? So other responsibilities of lexical analyzer is they are going to remove the white spaces if there are any white spaces opposite, after this, before it, and if there are any comments, if you might even write a comment, something like this. Whatever comment it is, this one will be deleted by lexical analyzer. So main responsibility is converting the program, the stream of lexemes means all these names, into stream of tokens, right? For example, id is x is an identifier, equal to is a operator, a is an identifier, plus is an operator, b is an identifier, c is an identifier, right? So how do you identify, how does the lexical analyzer identify that these are all identifiers and then these are all tokens is that is using some regular expression called patterns. So for example, an identifier can be like this. An identifier can be a letter followed by letter or digits, any number of them, a letter followed by letter or digits. This is called the pattern. If anything matches this pattern, then that will be automatically identified as an identifier. So the pattern will be known to the lexical analyzer before, which means you have to give it before you start everything. Now once you get the tokens, stream of tokens will be given to syntax analyzer. Now syntax analyzer is going to take all the tokens one by one, and then it is also going to take a grammar. It is generally called context free grammar. Why are grammars useful is, its main grammar's main use is this. The entire program, the rules of the programming language can be entirely represented in some few productions. Generally every program, every programming language, it will have some few hundreds of productions. Using these hundreds of productions, production means these rules, using these rules we can represent what a program actually is. For example, the meaning of these few productions is this: a statement can be identifier is equal to expression followed by semicolon. Okay, and now an expression can be expression plus term or term. A term can be term into factor or factor. A factor can be simply an identifier, right? So using these rules, your program has to be matched against them, which means the input has to be checked whether we have given it according to this format which we wanted. For this the syntax analyzer, it is also called as parser, it is going to construct a parse tree. Parse tree is going to start with the start symbol. Yes is the start symbol. A statement is identifier is equal to expression. An expression is expression plus term. A term is term into factor. Factor can be identifier, term can be factor, factor can be identifier. So finally what we get is a parse tree in which we can see the entire stream of tokens. In case if you don't see the stream of tokens, see the stream of tokens is this: id equal to id plus id into star followed by semicolon, right? Therefore you have to see that the yield of this parse tree and the input to the syntax analyzer both are same. If you get that, we can say that the input is according to the format we gave, otherwise there is a syntax error. Therefore syntax errors can be detected at syntax analyzer if the input is not according to the grammar given. Okay, now the output of syntax analyzer is a parse tree. This parse tree will be given to semantic analyzer, the next phase, right? So semantic analyzer is going to take the parse tree and verify it semantically in the sense whether it is meaningful or not. For example, it is identifier is equal to something, right? Now left hand side has to be a variable, it cannot be a constant, or it cannot be a function name, or it cannot be an array name. So left hand side has to be a variable which is compatible with the type of the right hand side. So all such type checkings have to be done at semantic analyzer. Okay, so output of semantic analyzer is going to be meaningfully verified parse tree. That is why it is called semantically verified parse tree. Now this semantically verified parse tree will be given to intermediate code generator. So intermediate code generator is going to generate intermediate code. There are various kinds of intermediate codes, but the most popular one in intermediate code is 3-address code. Why is it called 3-address code is, if you look at any line, there are only 3 addresses. For example, in this one, T1 BC, T2 AT1, X T2, which means maximum there can be 3 addresses. I mean, it can even be less. So the given statement is 4 addresses. Now we reduce the statement into 3 addresses. This is 3-address code. Why do you want to convert something into intermediate code generator is, if you can convert a program into intermediate code, then that intermediate code can be converted to machine language using the last 2 phases which are dependent on the platform. So till this part, whatever machine you are going to run the compiler on, this part is completely same. Which means if you want to design a new compiler for a new platform, you need not start it from the scratch. You can take all the phases till intermediate code generator and you can change the last 2 phases so that the new compiler can be formed. Okay, therefore if you are having an existing compiler, what you could do is just take it and then change the last 2 phases so that you get a new compiler for a new platform. For example, if your existing compiler is writing some code which will run on a computer, maybe if you want to do a code or write a code which will run on a mobile phone, just you change the last 2 phases, these 2 phases, you need not change everything. Okay, and then by taking this intermediate code, the code optimizer is going to reduce the number of lines. How many lines were there? 3 lines were there. If you look at the lines, first what are they doing is, first they are trying to multiply B and C. First they are trying to multiply B and C and then put it in T1 and then add a to t1 and then put it in t2 and then write t2 into x. Now by using code optimizer, we are actually reducing the number of lines. We don't need actually 3 lines to do this job, only 2 lines could do it. Okay, so that is why we are having code optimizer. Now the output of code optimizer will be given to target code generator. The main purpose of target code generator is to write the code which assembler can understand. You remember that, right? After the compiler there is a phase called assembler, and the assembler will be depending on the platform. Therefore, depending on what assembler you use, you have to write the this target code generator has to produce that kind of code. For example, now this is just an example I have taken. It need not be the same for all the compilers. So output could look something like this. I'm not saying that it is going to be always like this. No, we have how many variables? A, B, C. In case if we have moved A into R1, R0, B into R1, C into R2, then this code can be put in this way. First we are multiplying B and C. That is why multiply R1 and R2 and then storing it in R2 only. Therefore R2 will contain B into C, and then we are adding R0 to R2. Right? Why? Because T2 is nothing but adding R0 to R2, and then we are moving everything into X. Right? So this is actually X equal to A plus T1, and then we are moving everything into X. Right? So theoretically this is what all the phases are supposed to do, but then practically when you come to the practical implementation of compilers, we really don't have all these phases. Most of the phases or most of the jobs or the functions are done by syntax analyzer itself, which means the syntax analyzer is generally the heart of the compiler, which is even going to take lexical analyzer. I mean, when you implement it, you are not going to implement it separately. In the same module, you are going to implement even the lexical analyzer and the semantic analyzer also, and even intermediate code generator. Therefore, this entire part will be implemented together, which is also called as front end. So till the phase intermediate code generator, it is also called as front end. Front end in the sense the starting part of the compiler, and after that whatever is remaining, that is called back end. Okay, so back end we have code optimizer and target code generator. So in all these phases there is front end and there is back end. Theoretically the entire front end is implemented together, and then the back end. If you give any program normally, so front end will act on it first and then the back end. If you are interested in implementing a compiler, there are various tools available. So first thing is, for lexical analyzer there is a tool called Lex available in Unix. So you can implement lexical analyzer using Lex. And for syntax analyzer there is a tool called YACC, yet another compiler. And if you want to do any project on this compiler, there is a tool called LANS. LANS. So LANS is nothing but implementation of the front end of the compiler, which will give you intermediate code, and then you can implement back end on your own depending on the platform. Okay, so what I mean to say is, theoretically there are all the phases, but practically we have front end and back end. All the phases till this intermediate code generator are implemented together, and mainly they are implemented in syntax analyzer. Okay.